You may have a situation where you want to do more than a simple ANOVA. A simple ANOVA might compare one factor with multiple categories or multiple levels, is how we often talk about it. But what about the case where you have a data set like, for example, this one that's up shown in the upper panel here. In this data set, I have two factors, elevation and condition, and then I have actually three response variables that I might want to look at one at a time. And I might have hypotheses about each. So these data come from data collected by field ecology students on Mount Rose, which is a mountain in the Southern Olympics. Mount Rose had a fire in 2006 that burned up the side of a mountain and conveniently burned about half of a mountain and not the other half. So it's really easy to walk up a trail that bisects the fire line and sample on one side and get burned samples, and on the other side get unburned samples and compare them with elevation. And in this study, the students went and looked at stem growth of salal plants. They looked at pathogen number on salal, Gaultheria chalon plants, and they looked at the number of spiders on Gaultheria chalon plants. In each case, they had a separate hypothesis about how stem growth, pathogens, and number of spiders would respond to elevation and would respond to the condition, burned or unburned. So in the previous example, we just had species predicting height. Now, let's take stem growth as our first variable, and we want to know how both elevation and condition affect stem growth. So the first thing you need to do, as always, is import your data set. So this is the data set that is most likely similar to what you have in your folder that you'll be running for your lab. Okay, now to the heart of the matter. All of this has just been gabbing about the general kind of framework for the study and what we want to do. But you'll remember before we did a simple ANOVA, and we were able to do a simple ANOVA on seedling height by species. First, we plotted what we were looking for. Then we did an AOV command to look at the analysis of variance, to make sure an analysis of variance was run. Then we stored that command in a Word, and then we created a table from that. We can do the same thing with our data on rows here. So we called this rows, but what we might want to do instead is rename this data set. Of course, rows is even a shorter word, so it doesn't really matter. Now, data set contains all the rows data here, so I'm ready to do that. I'm also ready to do an AOV command, so I can do an AOV on the rows data. In this case, I'm going to do an AOV on stem.growth as predicted by elevation. And in this case, I'm going to multiply by condition. That multiplication will give me a full factorial analysis where it's going to analyze elevation, it's going to analyze condition, and it's going to see how the interaction of those two affects stem growth. And I'm going to use the data equals command to tell it that I'm looking at the data stored in data set. I'm going to skip a step from what I did before because I already know I want to store this in a term, and then I want to use the ANOVA command on it, which I could actually do in all one command, but let's take this one step at a time. I'm going to call the stem ANOVA. And I want stem ANOVA to store this command. So take a minute to write down this command if you haven't already. I'm going to hit enter, and now stem ANOVA is complete, and all I have to do is type ANOVA. Stem ANOVA. And you'll see it prompts up. Okay. Here's my analysis of variance table for the complete analysis, and you'll see that elevation and condition are both significant factors, and elevation by condition is also significant. If I use my up arrow to go back through my previous commands, I can also just go through and type plot here to plot my data. It'll prompt me to hit enter to see each plot one at a time. There's my elevation plot, and there's my burned, unburned plot. So a little earlier, I went through how to create an ANOVA for multiple factors and look at their interactions. Here we're looking at the ANOVA output table in RStudio and the effects associated with that. And then we slightly changed our script to just say plot, or box plot might work too. And that gave us a series of graphs that were plots of both of the factors that we were looking at. In this case, elevation, high and low. You can see the graph here on the right, affecting stem growth, and we can do the same thing for burned and unburned condition. But there's a problem because we also might want to look at how these things interact or don't interact, as the case may be. So it turns out there's another function that we can use, and it's called interaction.plot. So down at the bottom of your screen, you'll see some script. I'm going to expand this window here a little bit so we can see what we're dealing with. This script is the interaction.plot script. And you might remember from an earlier lab that there's a couple of different ways to call up a given variable in a data set. One of them is to use the plot function like we did earlier, where we specify the data set by the data equals command at the end of our script here. And that's one way to tell R what data you want to work with. So you can name the variables and then afterwards say, here's the data set that those are in. But another way to do that is to use the $sign command within the script itself. So this is especially handy if you're working across multiple data files. So for example, I could have written dataset $sign stem growth and dataset $sign elevation and dataset $sign condition. And then I wouldn't need the data equals command. And then I should get roughly the same graph. So it's going to have me run each plot one at a time. You see it's producing the same graphic for me. So the $sign command is a really handy command, and it also allows you to make sure that you're getting the spelling exactly right. So you get an auto prompt for the data set you're working with. You get an auto prompt for the variable in that data set as you begin to type it. So data set, and if I'm typing stem growth, I start typing STM, and it should eventually, yes, it sees that I want stem growth, and it'll auto prompt me to fill that out. So that's a handy way to make sure you don't have typos. Okay, but we want to look at something more complex, which is an interaction plot. So in our ANOVA, you'll remember that we had elevation as a factor, condition as a factor, and elevation multiplied by condition as a factor. How do the two interact? In other words, does the condition effect change depending on what elevation you're at? You can imagine that the effect of burning at high elevation could be different from the effect of burning at low elevation. So again, the effect of burning at high elevation could be different than the effect at low elevation. In this particular example, we already have a probability score that tells us it's not the case, but it can be helpful to see it. So I'm going to run this code instead, the interaction.plot code. And I'm going to take rows elevation and rows condition as factors affecting rows stem growth. So it's a little different way of writing it out than you're used to in the plot commands. Instead of the tilde specifying what is going to predict a y, we're actually listing our prediction and interaction variables first, and then we're listing the thing that we want to have predicted. So our independent variables first, and then our dependent variable. I've added some script in here that allows me to specify the name for the x-axis and the y-axis, and then a label for lines that I'm going to plot. So let's see what happens when I hit enter here. Okay, so I get a graph, and in this case, this graph is showing me 2 lines for each treatment, burned and unburned. And one thing that gets a little bit annoying in R is you'll notice that as we resize this window, the script and the graphic are going to automatically resize. So let's look at this more the way it might look if we were going to save it as an image. We can go through and we can adjust things like the width. I especially like the copy to clipboard command because it gives me a lot of options, but you'll notice it's putting my axis label in a place that's kind of hard to, or my treatment label in a place that's kind of hard to interpret. So you might have to mess with that to get that to work just right. So I'll leave that to you and and your exploratory capabilities. We can move around that label if we'd like to.